yesterday we have discussed about the semantic web in the artificial intelligence, right? Semantic networks. We have discussed its components. We have discussed the examples of it. So again, just revise. What is the semantic network, or what questions can come in this? Simply, we are covering 2 questions right now, and we will discuss about the partition semantic networks also, and we will see a diagram. And after that, we will discuss about the parallelism here. So what are the semantic networks and how it is different from the partition semantic networks? Simply, and what do you understand by the partition semantic networks is basically, it's simply when we are dividing a big system into a number of modules in a or we are dividing a system or subdivided in a number of modules, and we are making the other semantic networks. That means the big system is divided into a sub-modules here, and the big semantic network is divided into a parts of a semantic networks, which can be further collaborate to form a major semantic network. So what is the semantic networks are used in a other way, or in a other definition, we can say that semantic network are used for the graphical representations of interrelationships between the elements in a knowledge domain. Now, what elements we have discussed, and yesterday we have discussed the definition that it represents the linking or the relationship between the concepts, right? The different concepts here. So, which represented as a nodes and relationship between the concepts. So, here we are saying that we use the semantic networks in the artificial intelligence for the graphical representation of the interrelationship between the elements in a particular domain or the knowledge domain based on the pattern of nodes interconnected by the arcs. In semantic network, the knowledge is represented by labeled directed graphs whose nodes represent the domain elements and arcs. The relationship between the elements and the arc again are directed links and basically represent the binary relations here, right? And we have discussed yesterday in a limitations also that when there is beyond the binary relations need to be represented, it is a complex task in a semantic networks, or in a not in a semantic network, basically in a first order predicate. We have discussed yesterday about the first order logic. So originally semantic networks were introduced for the representation of a linguistic knowledge required for the machine translation, and that's why we have discussed the application of a semantic network as a natural language processing also. Today they have found general application knowledge representation in the various areas of AI, and we have discussed yesterday about the machine learning also is the application, and machine learning and the various expert system as an application of a semantic network. Thus, the semantic network is an alternative to predicate logic. But when there is a more than 2 relationships we need to represent as a form of a knowledge representation, we have discussed the predicate logic in the knowledge representation. And the idea is that we can store our knowledge in a form of a graph here. Now, we are talking about in form of a graph, and then a predicate knowledge, we have talked about the statements. A semantic network consists of a nodes connected by the arcs. Again, we are saying this nodes represent the objects in the real world or any real world entity here we are talking about, or simply we are saying that nodes in a semantic network are the objects in the real world. Arc represent the relationship between those objects, that is generalization, spatialization, or inheritance kind of a relationship. Inheritance is also possible in semantic networks. Inheritance, what do you understand by the inheritance? The parent-child relationship, right? So inheritance is a process by which the local information of a superclass node is assumed by a class node, a subclass node, and an instance node. So here the graphical representation with the various relationships according to the superclass and the subclass, and the parent-child relationship is represented by the semantic networks. So the semantic network-based knowledge representation mechanism is useful where an object or the concept is associated with many attributes, like when we are talking about a node which is associated with many attributes and where the relationship between the object is important. So here we are talking about the semantic network, and here you can see an example here. A person is an animal, a fish is an animal, and a cat is an animal. And here again we are saying that eat, cat is eating a fish, or sushi is like the fish, right? And Zim, another, is a person. So here we can see a diagram here that is representing a semantic network. Now you can see here the relationship between the various concepts here, right? And the superclass and a subclass relationship is also here. Is a kind of a relationship is also here, and which belongs and right is also here. Now, how the semantic network is different from the partition semantic network? A partition semantic network is a semantic network which can divide it into one or more networks for the description of an individual network, right? So when we are talking about the division of a network, when we are talking about the relationships also, we are making the sub-module also. So we are basically dividing, we can divide one or more networks for the description of an individual network. When we are talking about the detailed network about a particular node here, the main idea of partitioning is to allow the groups, nodes, and arc to be bundled together into units called the spaces. So here the spaces is the another component when we are talking about the partition network. Spaces are the fundamental entities in the partition network on the same level as the nodes in the arc. Or simply we are saying that every node and every arc of the network belongs to one or more spaces here. Or some spaces are used to encode a background information or the generic relationships. Simply, we are saying that when we are spatializing, when we are using a spatialization relationship, simply we are partitioning a particular node into a number of sub nodes here, and we are using a partition relationship. And when we are saying that, when we are collaborating the different nodes and we are forming the topmost node or the generalization, we are saying the generic relations here or the relations here. So in both cases, the partition network is used, or simply when we are representing any top to bottom approach, then we are basically dividing a particular node into a certain nodes with the help of a spatialization relationship. And when we are talking about bottom to top approach in a graphical representation, when we are representing a generalization relationship, when where we are combining two or three nodes based on a common property and forming a base node. So in that case, we are basically talking about the generalization, right? And the spatialization form and the generalization form of the networks basically are the partition semantic networks. Now, we will discuss about the difference between the semantic networks and the planes. Then we will discuss about the planes also. Yesterday, we had completed the applications of a semantic networks, right? We have discussed about the NLP, expert system, ontology development, information retrieval, and the machine learning. We have discussed about the advantages also, or we were discussing about the advantages of a semantic networks. What are the advantages here? Intuitive representation, flexibility, and the support for the reasoning. We have discussed these advantages. Now, what are the challenges and the limitations of a semantic network? we need to discuss this. So while semantic networks are powerful, they come with a certain challenges here. First is the scalability. So what is the scalability? Scalability is basically extending the networks. So simply we are talking about the complex network will be formed. So as the number of concepts and the relationship increases, then we are talking about the semantic networks can become more complex and difficult to manage. Then we are talking about the ambiguity. Ambiguity meaning is basically when the one node is having a number of meanings, right? Or when the same meaning is having the two nodes. So representing ambiguous or unclear relationships can be challenging, leading to the potential misinterpretations by the AI system. Simply when we are saying when two are having the same meaning, so what is the correct one, right? So differentiation between that will be difficult for the AI system, or simply when we are representing the unclear relationships or the ambiguity or the redundancy in our networks that can be cause the misinterpretation by a particular AI system. And is the computational complexity. When we are talking about the number of relationships and the nodes are more, or the concepts are more, and when we are talking about the complex networks here, with the complex network meaning, we are saying that complex network with the numerous relationships can require significant computational resources to process and reason about it. So what is a semantic network? Basically, semantic networks play a crucial role in artificial intelligence by providing a structured and the intuitive way to represent knowledge and the relationship between the concepts here that we have discussed here. And in the when we are talking about the applications here, then NLP expert system and other AI applications are used by the semantic networks, or simply the main application that uses semantic network is the linguistic conversion or the NLP or the natural language processing. And when we are talking about the challenges here, the semantic network remains fundamental tool in the AI toolbox, helping systems to better understand and process the vast amount of information they encounter. So what are the parallel implementations of a semantic network? We have discussed about the partition. Now what is the parallel implementations? Or simply what do you understand by the parallel? We are simply saying that when the functionality is going parallelly. So parallel implementation of a semantic network refers to the use of a parallel computing techniques to efficiently process and manipulate the semantic network. Or simply when we are saying that when a particular data is distributed into a number of nodes, then the processing of a data that is divided into a different parts will be done parallel here. Or simply we are using the parallel computing techniques to efficiently process and manipulate the semantic networks, which is basically showing the data only in the system. So parallel computing involves the simultaneously execution of multiple tasks or the processes to improve the performance and speed up the computation. क्या कोई example दे सकता है parallel processing का, or a real world example of a parallel computing here? Can any one of you give an example here? As we have discussed, हमने पहले भी बहुत बार डिस्कस किया है
पैरेलल प्रोसेसिंग में जनरली कोई बिग टास्क होते हैं ना, उसको कंटिन्यूअसली अलग अलग या तो डिस्ट्रीब्यूटेड सिस्टम के थ्रू सॉल्व करते हैं, या अगर थ्रेडिंग की बात भी करें किसी प्रोग्रामिंग लैंग्वेज में, तो अगर थ्रेडिंग का भी अचीव कर रहे हैं किसी बड़े टास्क को फर्दर डिवाइड करने के लिए, तो वो भी एक पैरेलल प्रोसेसिंग ही कर रहा है। अगर हम इंडिविजुअल पीसी की भी बात करें तो उसमें एक से ज्यादा सीपीयू यानी कोर जो लगे होते हैं, वो भी अलग अलग टास्क को अलग अलग कोर्स के द्वारा करते हैं, तो वो भी एक पैरेलल प्रोसेसिंग है।
हाँ जी, सिंपली आपको मैं इसका छोटा सा एग्जांपल और बताती हूँ। लाइक अगर हम कोई बहुत बड़ी डेटा फाइल जो है उसमें अगर हम डिस्ट्रीब्यूटेड सिस्टम वे में उस फाइल को स्टोर करते हैं, मतलब उस फाइल को फर्दर ब्लॉक्स में पार्टीशन करते हैं, देन पर्टिकुलर ब्लॉक्स को हम अलग अलग नोड्स में जाकर स्टोर करते हैं, दैट नोड्स हैज बीन स्टोर्ड, राइट? वन डेटा इज डिवाइडेड इनटू अ नंबर ऑफ ब्लॉक्स हियर, एंड देन देयर इज अ task of processing that data or changing that data or updating that data read-only case, maybe we will do the parallel processing or we can do anything. But when we need to write our data, or when there's a different application of that particular blocks are present, because we have used the distributed way of storing that data, right? अभी जो इंटरनेट की बात करें, like every time in every minute the vast amount of data has been generating. So उसको store करने का जो तरीका है, that is we are using the distributed way. In a distributed way the data is getting stored here. ऐसा नहीं सारा डेटा एक ही जगह स्टोर हुआ हुआ है, एप्लीकेशंस भी यूज कर रहे हैं और ब्लॉक्स में भी डिवाइड कर रहे हैं. लेकिन जब आप सर्च करते हैं डेटा को, राइट, और या उस डेटा में कुछ अपडेशंस परफॉर्म होते हैं या एडिशन होता है उस डेटा में, कुछ भी रीड एंड राइट, कुछ अपडेट होता है, मैनिपुलेट होता है वो डेटा, in that case the parallel processing is used. Why the parallel processing we are saying that? Because अगर हमने उसके एप्लीकेशंस क्रिएट किए हैं और डिस्ट्रीब्यूटेड में अगर डेटा को हमने स्टोर किया हुआ है, तो इन दैट केस if we will not use the parallel processing, ये पॉसिबल है कि एक कॉपी में तो वो अपडेट हो जाए, दूसरी कॉपी में वो अपडेट ना हो. So in that case we need to use a parallel computing techniques. We need to use a parallel processing so that कि हर जगह एक संग पूरा डेटा process properly. So here in terms of why I had taken an example of a data here, because हम यहाँ पर knowledge representation की बात कर रहे हैं. We are talking about the knowledge representation and we are talking about the knowledge representation. That means we are basically preparing a machine to work as a human here by how we are preparing a machine by inserting a lots of data. बहुत सारा डेटा उसको स्टोर करके दे रहे हैं, उसमें बहुत सारी टेक्निक्स हम यूज कर रहे हैं जिससे वो डेटा को यूज करके लर्न करे एंड देन फर्दर कोई भी प्रॉब्लम का हमें सॉल्यूशन प्रोवाइड करे. सो पैरेलल कंप्यूटिंग इज वेरी इंपॉर्टेंट इन दैट केस बिकॉज नॉलेज बेस इज वेरी बिग. बहुत ज्यादा अगर डेटा है और उस डेटा को अपडेट करना है, मैनिपुलेट करना है, तो समवेयर वी आर यूजिंग अ पैरेलल कंप्यूटिंग टेक्निक देयर which involve the simultaneously execution of a multiple task. बहुत सारे काम एक संग हो रहे हैं और processes to improve the performance and the speed of the computation. मतलब अब सिंपली अगर किसी प्रॉब्लम का सॉल्यूशन चाहिए और वो डेटा डिफरेंट ब्लॉक्स में उन सारे डेटा को कंबाइन करना है, तो समवेयर मल्टीपल टास्क विल बी एग्जीक्यूट साइमल्टेनियसली. So when applied to the semantic networks, which basically what the meaning of a semantic is simply a meaning, right? तो meaningful networks जो हैं उन पे अप्लाई किया जाता है. Then parallel implementation aim to leverage the computational power of the multiple processors. ठीक है, multiple processor एक ही साथ काम कर रहे हैं और computing resources to enhance the knowledge processing capability, right? So knowledge को process किया जा रहा है. Simply एक ही टाइम पे multiple चीजें हो रही हैं. So here are some aspects to consider when implementing semantic networks in a parallel computing environment. कब हमें semantic networks को implement करना है? So first is the parallel processing units or the partitioning of a semantic networks. We have discussed about the partition semantic networks. So we are using the parallel computing in a semantic when we are partitioning or when we are dividing or distributing here in a semantic network. So what are the parallel processing units? In parallel implementation, the processing units can be multiple processors with a single machine, right? Or a cluster of machine, or even a distributed computing resources are here. Here in a term of a data, we are saying the resources of data here. These units work concurrently to perform the computations on a different parts of a semantic network, enable the parallel processing. Here we are using, then we are using it in a partitioning of a semantic networks. How? Semantic networks can be partitioned into a small subset. The partitioning of a semantic net. So semantic net, we have discussed about the distribution, right? We were discussing about the distribution of the data. We have taken the example of a distribution of a data or storing of a data in a distributed way. So semantic networks can be partitioned into smaller subsets to be processed independently by the different processing units. And each unit can focus on specific portion of a net. In a partition net, we have discussed this. Perform the computations and exchange information with the units as needed, and the partitioning strategies can be based on the structure of the net, domain-specific considerations, and the load balancing requirements also. In that case also, then we need to process the data in a different nodes parallelly, we can use the parallel computing here. Now the task allocation and the synchronization is there. Simply when the data is divided or when something is divided in a distributed manner and when we are using a partition manner, we need to synchronize the task here or the task allocation, and we need the synchronization between the resources or the nodes. The processing unit needs to allocate here the specific task or the computations to perform on a semantic net, and the synchronization here mechanism we are using are employed to ensure that the unit collaborations and the share information effectively, because we are using the partition networks also, right? So communication protocol and the techniques such as the message passing or the shared memory are used to exchange data and the results between the processing unit. Now, what do you understand by the parallel inference and the reasoning? Simply, when we are talking about the meaningful networks, which is defining the meaning of a concepts in a form of a relationship. So somewhere the reasoning will be done by a machine. How the parallel inference and the reasoning will be performed. Inference and the reasoning task is the another task which is need to be implemented by a semantic networks here, such as the semantic matching, deduction, or the probabilistic reasoning, can be parallelized to exploit the parallel processing capabilities here. Or the different units can perform independent inference here, inference tasks, and combine their result to reach to a conclusions or the make the decisions, which basically give the insights of a data here when we talk about in a form of a data here. Then the parallel knowledge acquisition and the learning is the another task which needs to be performed by the partition semantic networks we are seeing there. So what do you understand by parallel knowledge require gathering here and the learning? In addition to the knowledge processing, parallel implementation can be applied to the knowledge acquisitions and learning processes here, where the multiple units can simultaneously process, as we are talking about the parallel computing, and analyze a large amount of a data to extract the knowledge and update the semantic network, right? We need to learn, we need the data, we need to process a large data, and we need the analysis of that data so that we can get the insights from that data. So to get the when we are analyzing a large amount of a data to extract the exact knowledge and to update the semantic networks according to that knowledge. Again, as you had also given the example of a load balancing here, where we are using a semantic network. So load balancing efficient. Load balancing is a crucial in any kind of a system to achieve a good performance. So in a parallel implementation also, so load balancing techniques ensure that the computational workload is evenly distributed across the processing units so that they can work efficiently or the good performance will be achieved, preventing the bottleneck and maximizing the resource utilizations, right? Every time the resource should be available and the resource will be utilized in a proper efficient manner. Now then, we are talking about the scalability. Scalability is simply the parallel implementation of the semantic network should be designed to scale so that it can be extended, so that the modules can be further added with the size of a semantic network and the available computing resources. And here we are also talking about the parallel processing of a data so that the whatever the scalability we are talking about, the extending of a data we are talking about, the system should be able to handle the large networks and accommodate the additional processing unit seamlessly. So what do you understand by the parallel implementation of a semantic network is basically when we are talking about the partition semantic network, somewhere we need to import a parallel computing technique here, and the network can significantly enhance the processing and the reasoning capability of a knowledgeable system with the help of a parallel implementation of the semantic networks. It allows a faster knowledge retrieval because of a parallel processing of a data, efficient reasoning because of a learning of a or getting the exact knowledge about a from a particular large data by performing the various data analyst operations, and better utilization of our computational resources because of a load balancing here. However, designing and implementing parallel system require a careful consideration of various factors such as the data partitioning. When we are talking about the data partitioning, when we are dividing the data and storing that data in a distributed manner, or when we are dividing a particular file into a number of blocks, that we need to be very careful so that the data should not be lost. And then we are talking about the load balancing and the synchronization that need to be done in a good condition so that the efficiency that we are talking about, the parallel implementation should be achieved, and the scalability, and to ensure the effective utilization of a parallel computing resources here simply. So here we have discussed about the complete semantic networks, we have discussed the graph also, and we have discussed about the partition semantic network, and we have discussed about the parallel implementation of the semantic networks also. Another thing which we need to discuss when we are talking about the knowledge representation is the frames. So we are talking about these techniques in the knowledge representation techniques, right? First, we have discussed about the knowledge representation technique, which is the first order predicate or the first order logic or the predicate logic. And then we have talked about the semantic networks. Then we have talked about the different components of a semantic networks. And then we have talked about the partition semantic networks. And then the parallel implementation of the semantic networks.